In this question, we have to identify information about the silver compound is shown. The question is, which equation shows a reaction which cannot be used to make a silver salt? So, example, when we mix two solutions here, it will form precipitate or solid which can be removed by filtration. So that is correct. We can prepare the salt by this technique. Silver oxide reacting with nitric acid gives silver nitrate and water. So this metal oxide can also react, like metal oxide react with acid, give salt and water. Metal carbonate can also react with acid, give salt, water and carbon dioxide. But what about option D? In option D, as we know, the reactivity series, we have potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, mercury, silver, gold and platinum. So elements which are below lead, they don't react with acid, the dilute acids which we use in the lab. So these elements are not having any reaction with acid. So if you have a silver metal and we mix HCl, we are not able to form this. Why? Or this reaction will not occur. So if this reaction cannot occur, we cannot use this technique to prepare a salt, because we know acid can react, like this is a precipitation reaction. When we mix two solutions, it can be any solution, acid or salt, two salts. So precipitation reaction is there, this can be done. When metal oxide, this is a silver oxide or metal oxide, react with nitric acid, give salt and water, that is can be done. Metal carbonate react with nitric acid, give salt, water and carbon dioxide, that can be done. Metal react with acid, give salt and hydrogen, that is true. But that is not true for the elements which are below lead, because elements which are below lead, they are not able to react with acid. So as they are not able to react with acid, we don't observe any reaction, so we cannot prepare a salt by the fourth technique. Question 19 is about the types of the oxides. Some properties of the four oxides are listed. Oxide 1 react with both acid and alkali. So if it react with both acid and alkali, it means it is amphoteric. Oxide 2 react with acid but does not react with base. So the oxides which can react with acid, they are basic oxides. Because a basic oxide or base can react with acid, they react with alkalis. So if it react with alkali, then what kind of oxide is this? Acidic. Because acidic oxide can react with alkali, they don't react with acid. Because acid, they don't have observable result or change. Then does not react with acid or alkali, the oxide which does not neither react with acid nor react with alkali, we call that as a neutral. So oxide 1 is amphoteric, oxide 2 is basic, oxide 3 is acidic, and oxide 4 is neutral. That is why B is the right option. Is it clear? Question 19. Then what is not a typical characteristic of acid? Like what does not happen with acid? Acid react with alkali to produce salt and water, that is true. They react with all metals to produce hydrogen, that is not correct. Why it is not correct? As we discussed already, that all metals does not react with acid. The metal which can react with acid, they are more reactive metal like potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, mercury, silver, gold, platinum. So these metals are not able to react with acid. So that's why B is not the typical characteristic that all acid react with carbonate to produce carbon dioxide and acid turn blue litmus red. That is also true. So the one which is not correct, that all of the acid react with metals. Is it clear? Discussion. Then zinc sulfate. Zinc sulfate is a soluble salt because most sulfates are soluble except barium, calcium and lead. So we want to prepare a soluble salt. So how we can prepare a soluble salt? Either we can use evaporation or crystallization. These are the two techniques which can be used. So if you want to prepare, which process, the excess of zinc oxide is removed from the solution. Now which process is used to obtain zinc sulfate from the solution? So if we have soluble salt, the salt is dissolved in water, we want to obtain it. So which technique can be used? We can use either evaporation or crystallization. That's why A is the right answer. Then copper 2 sulfate can be prepared by adding excess of copper 2 carbonate with sulfuric acid. Why is excess of copper carbonate is needed? Like why we use too much copper carbonate? Basically what happened when we have copper carbonate, it reacts with sulfuric acid which is H2SO4. As a result it will form copper sulfate plus water, or copper carbonate is there, sorry. This was copper carbonate. So copper carbonate react with acid, gives copper sulfate plus water plus carbon dioxide. Now, why we use excess? What is the reason why too much is used? So what is the reason for that? Because we want to make sure that all of the acid has reacted, to ensure like no more acid left unreacted, because this excess of copper carbonate can be removed by filtration. So what is the purpose? Why we are adding excess or more than enough copper carbonate? To ensure that all of the sulfuric acid has reacted. Because if some of the sulfuric acid might not react, so the solution will have both sulfuric acid and copper sulfate. Three solids are there, P, Q and R, all react with acid to produce zinc sulfate. P and R produce gas. The gas produced by P will not burn, but the gas produced by R will burn. What are P, Q and R? So first thing, because when they are reacting, when P is reacting with acid, Q is reacting with acid and R is reacting with acid. So what it gives? It gives zinc sulfate. So it means, because if something react with sulfuric acid, it will be sulfate, and the metal which is present here is zinc. So P plus sulfuric acid, H2SO4. They mention here P and Q, P and R are giving the gas. So P react with sulfuric acid, give a gas. So which two cases acid can give a gas? When acid react with metal, possibility when acid react with metal it will give a gas, because acid react with metal it will give salt and hydrogen gas, and hydrogen is a flammable. Or acid react with metal carbonate. So when metal carbonate react with acid, that will also give salt plus water plus carbon dioxide. So the carbonate reaction with carbonate or reaction with metal give gases. So P and R, either P and R can be metal, one of them can be metal, and other one is metal carbonate, because these are the two conditions in which a gas is given off. But they mention when P is producing a gas that does not burn. So which gas does not support the burning? Carbon dioxide is produced in the combustion, but it does not support burning. It does not help in burning. So it means P is a carbonate, because when it is a carbonate, it gives carbon dioxide which does not support burning. And R is a gas which burn. So hydrogen is a flammable gas, it can burn. So it means R is a metal, where P is a metal carbonate. So P is a metal carbonate which is like zinc carbonate, and R is a metal. And then we are left with, so metal carbonate is there and metal. So the option which we are left with, that Q can be zinc hydroxide. That's why C is the right answer. Is it clear discussion that why C is the right answer? Because P is producing a gas which does not burn, and carbon dioxide gas does not burn or support combustion. And R is producing a gas which burn, it means it is producing a hydrogen, as hydrogen can catch fire. So that's why R it means is a metal which is producing a hydrogen gas, and P is a metal carbonate which is producing a carbon dioxide gas. So P is metal carbonate, like metal zinc carbonate. So either B will be answer or C, but R is a metal, so that's why C is the right answer. Then the part of the periodic table is shown which element form an oxide that can react with acid to form salt. So they're talking about the basic oxide. In a periodic table, on the left hand side we have metals. Metals form a basic oxide. On the left hand side of a periodic table, mostly metal. On the right hand side we have non-metal. So this is a non-metal, non-metal, and non-metal. And non-metal oxides, what kind of oxide they have? They have acidic oxide. Whereas C is a metal, what kind of oxide C will have? It will have a basic oxide, and basic oxides can react with acid. That's why C is the right answer. Then question 25 is related to identification of the ions. When we add sodium hydroxide, a sodium hydroxide is added and a gas is produced which turn damn red litmus blue. So when sodium hydroxide is added and the damn red litmus blue turn blue, so it means it contain ammonium ion. So what is Q? So it contain ammonium ion, or it's ammonium salt. So directly C is the right answer, because ammonium salts in the presence of alkali, when we heat, gives off ammonia gas which is having a pungent smell. In question 26, potassium hydroxide is a base. So which statement describe a reaction of potassium hydroxide? Chlorine is formed when it is heated with ammonium chloride. Chlorine is not formed, ammonia is formed, because when we have ammonium salts, means salts which are having ammonium ion, and we add an alkali and heat it, as a result it give a pungent gas which is ammonia. So that's why A cannot be an answer. It turned a universal indicator green. Universal indicator having a different color at different pH, because it's a base or alkali, so it should be either violet or blue. Green means it is neutral, so that is why it is wrong. It react with acid to produce salt and water. So potassium hydroxide or base can react with acid to produce salt and water. That's why C is the right answer. It turned methyl orange red. That is wrong. Methyl orange is in acidic condition it is red, but in alkaline condition it is yellow. So here it's written methyl orange will be red. That is wrong. It is not an acid. It is a base, and base don't turn methyl orange red. It will turn into yellow. Is it clear? Discussion 26. That which statement describe potassium hydroxide or a base? In 27, some general rules of solubility are there. They give you the even the table. In this one, they already gave you the table. They're asking which substance produce insoluble salt from aqueous solution. Like when we mix two solutions. Example, if we mix the first one, barium chloride plus magnesium nitrate. So what will be the product? The product will be, because barium will take position of magnesium and magnesium take position, so it will produce magnesium chloride plus barium nitrate. So magnesium chloride plus barium nitrate will be there. So we have to check, because we want to produce a salt by precipitation here, like we want to produce insoluble salt. So magnesium chloride, when we check, magnesium chloride is a soluble salt. So this will be soluble, or solution will be there, and all nitrates are soluble, so this will be solution. So the first option does not produce insoluble salt, so it cannot be an answer. When we check the second option, calcium chloride plus ammonium nitrate. So what will be the result? Ammonium will take position of calcium and calcium take the position of ammonium. So as a result, it will produce ammonium chloride plus calcium nitrate. So again, you see, when we check ammonium chloride, most chlorides are soluble. So ammonium chloride is a soluble, like it will form as a solution in dissolved one. And all nitrates are soluble, so this will also be a soluble. So it won't give any solid. So we cannot obtain any salt from this technique, because both salts which are formed are soluble. When we check the third option, silver nitrate plus zinc chloride, when we mix them together, as a result, what it produce? It will produce silver chloride plus zinc nitrate. So silver chloride plus zinc nitrate are produced as it displace each other. And silver chloride, what is silver chloride? You can see most chlorides are soluble except lead and silver. So this will be solid, not solution, and this will be solution. So we can obtain this salt, the insoluble salt. That's why C is the right answer. Is it clear? Question 27. Because we want to prepare an insoluble salt which can be prepared by this technique. Which row are oxides correctly placed? So acidic oxide means non-metal oxide, and basic oxide means metal oxide. Like acidic oxide means it contain non-metal, oxygen with non-metal. And basic oxide means it contains a metal. So when we check magnesium oxide, this is a metal, so that is wrong. When we check magnesium oxide, and sulfur is non-metal, but magnesium is metal. But acidic oxide should contain a non-metals only. So sulfur dioxide and carbon dioxide. Yeah, that's right. So, and here calcium oxide and magnesium, that's why C is the right answer. So acidic oxide contain non-metals only, and basic oxides contain metal. Amphoteric also have metal, but there are only few metals which can undergo uh, and form an amphoteric oxide, which can react with both acid and alkali. The three examples you have to learn: lead, zinc, and aluminium. Now again, this is also related to identification of the ions. When dilute sulfuric acid is added to X, a colorless solution is formed and a gas is produced. So when colorless solution is formed, a solution does not have color. Look, first thing, metal oxide plus acid. So metal oxide plus acid will give salt and water, but there is no gas. And metal oxide again plus acid gives salt and water. So A and B cannot be an answer. We'll check option C and D. So option C, it will give, because it is a carbonate, so it will give salt, water, and carbon dioxide. And the salt solution will be there, plus water will be there, plus carbon dioxide. Here as well, it will form salt, water, and carbon dioxide. But they mention it is a colorless solution. So colorless solution or white solid, what gives an idea or indication that it means either group 1, group 2, or group 3 elements are present. So when group 1, 2, 3 elements are present, it means that is colorless solution, or if it is a solid, it will be white solid. So it cannot be C, because C is a copper 2. Copper is having a colored solution. Sodium belongs to group 1. That's why it is sodium carbonate. Is it clear? In question 30, few drops of methyl orange. What is a methyl orange? Methyl orange is an indicator. During the reaction, a gas is produced and methyl orange turned from red to orange. So red means it was acidic. Originally acid is there, and turned into orange, it means it turned into alkaline. So, or acid is completely used up and the gas is given off, as they mention here. So when sodium hydroxide react with ammonium chloride, sodium hydroxide is a base. So originally it should not be red here. If so, as you can see, sodium hydroxide is a base. It can react with ammonium salts and it will give ammonia gas. But the solution, because if there was sodium hydroxide, it means methyl orange should not be red, because methyl orange is red in acidic. So originally we should have acid. So why B cannot be an answer? Again, sodium hydroxide. Sodium hydroxide means it is a base. So in a base, methyl orange is originally orange in color, but in the question they mentioned methyl orange was red, then it changed to orange. So originally there should be acid. That's why A and B cannot be an answer. We are left with C and D. But why we select C? As you can see in option C, hydrochloric acid react with magnesium. So acid react with metal. What it will give? It will give salt. It will give hydrogen. So a gas is produced. But in option D, when acid is reacting with the base, there is no gas given out. It will produce salt solution and give off water molecule. So salt and water will be there, but it does not produce a gas. Gas is only produced when acid react with carbonates or acid react with metal. That's why C is the right answer. Then which substances produce insoluble salt? When barium chloride mixed with magnesium nitrate, it will produce magnesium chloride plus barium nitrate, so both will be soluble. When we check the second option, when it will form ammonium chloride plus calcium nitrate, both will be soluble. When zinc nitrate is added to when silver nitrate added to zinc chloride, so it will form zinc nitrate and silver chloride. So silver chloride will be insoluble. So we want to prepare an insoluble salt. So that's why C is the right answer. And when sodium carbonate react with potassium, so all group 1 salts are soluble, so it will not form any insoluble salt. In question 32, the results of some experiment with sulfur dioxide are shown. Which results are correct? Sulfur dioxide is acidic because it's a non-metal oxide, so it is an acidic oxide. So when we check the options, so sulfur dioxide, which is an acidic oxide, it mixed with hydrochloric acid. Like if we add hydrochloric acid, does not react. That is true because if acidic oxide is there, if acidic oxide is mixed with acid, there will be no reaction. So one is correct. When we check 2, when we add sodium hydroxide, hydroxide here refers to base. When base is added, a salt is formed, so that is right. When we have acidic oxide can react with base. When universal indicator is added, it turned purple. Turned purple means because universal indicator shows a different color in different medium, but universal indicator at in alkali it should be purple, but in acid it should be red or yellow or orange. So that's why this is not the right result, because acidic oxide, if it dissolve in when it dissolve in water, it will make the solution acidic and turn the universal indicator color won't be purple. Purple color means it is basic. And the last one, when acidified potassium manganate, this is actually a test for sulfur dioxide. As yesterday I showed you how the purple potassium manganate changes to colorless by the presence of sulfur dioxide. So A is the right answer. So 1, 2 and 4 are the right results. Then question 33. A white precipitate is produced when a small amount of two colorless solutions are mixed. Which pair of a solution produce a white PPT? When sodium hydroxide react with zinc nitrate. This is actually, you have to basically learn the test for the ions. So you can answer accordingly. This is when sodium hydroxide react with zinc salt, it give white PPT. When sodium hydroxide react with aluminium salt, it also give white PPT. When barium chloride mixed with sulfuric acid give barium sulfate, that is also white PPT. And when barium nitrate mixed with potassium sulfate, so this give barium sulfate, that is also white PPT. So all the 4 options are correct. This is related to identification of the ions, and you can just answer this question by memorizing the observation and the test. Question 34. Solution Q is warm with ammonium chloride. In the separate experiment, Q is added to methyl orange. So Q is warm, which substance we normally warm an alkali with ammonium salt to give off ammonia. So when it warm with ammonium chloride, what will happen? It ammonia gas will be produced, and when we add methyl orange in acidic condition, if acid is there, it will be red, but in alkaline or basic condition, it will be yellow. So what is the appearance? The methyl orange will be yellow because it's alkali, and the gas which is produced is a ammonia gas. So then the structure questions are there that we will discuss in the next session. So today we have completed multiple choice question related to topic acid, alkali and salt. This is a very important topic related to exam point of view, especially paper 6. There are a lot of questions related to identification of the ions. Any question or a doubt related to the class?